Hello students, this is Dr. Diaz, and today we're gonna talk a little bit about stoichiometry. So let's do it. So I'm gonna share my screen with you. Just a second. So took the screen, and then we go to my whiteboard over here. Oh, this is my whiteboard. Can you see that? Let me see my whiteboard. So let's start. This problem here is asking you the mass of oxygen needed to burn 36.1 grams of P2H6. So here is the given data, right? We have 36.1 grams. And he asked us to calculate the mass of oxygen. First thing you need to remember, look at the reaction, and if it's not balanced, you're gonna balance the reaction. Second thing that you need, remember, the stoichiometry, we're gonna go mole to mole. So we cannot ever start with grams. So if we have grams, right, we need to get moles, and to get moles, we're gonna need molar mass. And if you need to find out any other mole, the number of moles of any other product or reactant, what you're gonna need to do is to use the mole ratio of the equation. So the equation ratio. And what is the equation ratio? Is the coefficients that you see in front of your molecules over here. So this is why it's so important to balance, because here we see like 1, 1, 1, and 1. So it's 1 per 1 per 1 per 1. So it's bad because it's not well balanced. I can see directly because we have a B2 over here, and here have only one B, right? And then we're gonna have moles. But if the problem asks you to find, let's get back to the color. So if the problem asks you to find grams, what you're gonna need is the molar mass again. But now is molar mass of the product or reactant that you're looking for, okay? So let's start with the balance. Let's go a little bit on this side. So we're gonna copy this equation here to work better with you. So we have H2BO2 and I have water, right? So in this side, I have boron, hydrogen, and oxygen. And this side, I have boron, hydrogen, and oxygen, right? So in this, I have 2 borons, 6 hydrogens, and 2 oxygen. And here, I have just 1 boron. 1 hydrogen plus 2 hydrogen, I have 3. And I have 2 in here, and I have 2 plus 1, I have 3 over here. Okay, it's nothing, it's balanced over here, right? So let's go and balance. Let's start over here. Let's go another color. So the first thing that I'm gonna do is remember that I can use macho. So we're gonna start with metals. We don't have no metals. We have carbon, we don't have hydrogen, and I have oxygen. So I'm gonna start with no metals. So I have bottom over here. So it's 2. It's kind of metal, no metals, right? It's no metal. So it's 2 over here, and here have 1. So we're gonna put 2 over here. So we're gonna have 2, right? So now I have 2 protons, and I have 2 plus 2. I have 4 hydrogens, and I have 2 times 2 is 4, right? See, this is 2 times 2. So I have 4 oxygens over here, plus 1 over here, we have 5. Okay, so we fixed the bottom. So now we go to hydrogen. How will I fix the hydrogen? So it's missing over here, right? So 2 times 2, oh, that's 4. Now I have 2 hydrogens and I have 2, that's 4, right? So, but I need 6. So if I put over here 2, I'm gonna have a 2 hydrogen plus 4, which is 6, right? Because you need to multiply over here. So now I have 6 hydrogens. And look at this, 2 times 4 plus 2, because now this is 2 times 2 and 2 times 1. So we have a 2. So we can have 6. Okay, so we fix boron, we fix the hydrogen, and now let's fix the oxygen, like again, huh? So here I have 6. How are we gonna fix over here to 6? So to have 6, I only need to multiply 3 times 2, right? So it's 6. So now I have that. So my well-balanced equation will be 1, 3, 2, and 2. So I have my mole ratio of boron and oxygen. So we have 1 for 3, right? 1 mole of B2H6 will react with 3 moles of oxygen. So let's go to our calculation. So to start, we're going to start with the given data. So 36.1 grams of B2H6. And then you're going to have to find the moles, molar mass. So molar mass will be 2 times, go to your period table, and you're going to find over there in your period table. So we're going to see boron. Boron is in the group 13. So the valence electrons, what is the valence electrons over here? Think about it. So 10.8 or 1, 2, or 9 something. So I'm gonna just round the number. So we'll be 2. Let's put it here. Oh, let me erase this, is bad. So that's 2 times 11. And we have hydrogen. So hydrogen is 1. So I have 6 hydrogens times 1. So I have 22 plus 6, which is 28 grams per mole. So here we have 28 grams. Why? You always put in the opposite side of the unit. Say grams. Grams, it's over here down. Grams of B2H6. 1 mole of B2H6. Great, right? So this is the part that I showed over here. Now I need the equation ratio, because what I need to find is the oxygen, right? So what I need is oxygen. So 3 moles of oxygen will react with 1 mole of B2H6. See, this part over here is what I told you to look at the reaction to see if it is balanced, right? So we have this. Let's go to, with this, look at this. I can cut off this with this. I can cut grams with grams. And now I have moles. But this is not what the problem asking me. The problem asked me to find the mass of oxygen. So now I will need the molar mass over here, right? But in the molar mass of oxygen, which is 2 times 16, so 32 grams per mole. So I have 32 grams of oxygen per mole of oxygen. So we cut off, and you're gonna have your math. So it will be, don't forget to put parentheses in your calculator, please, because you get errors. Because if you don't use parentheses, what's gonna happen? They gonna only divide the last one. It's bad. So put parentheses, okay? calculator is not, they are not smarter than you. So you need to give information 36 times 3 times 32. I'm avoiding number 1. Okay, 28 grams. So we're gonna have, so grab your calculator and do the math. So we're gonna have 36.1 grams, right, times 3 times 32. That will give you a very big, huge number, and you're gonna have 100 divided by 28 will be 124 grams of oxygen. Okay, this is how you do stoichiometry. So important thing, balance, and know that you always use mole to mole. If you have grams, you need to convert to mole. If I have molecules, you need to convert to mole. Okay, molecules will be you're gonna use Avogadro, which is 1 mole. This corresponds to 6.022 times 10 power 23 particles or molecules or atoms. Okay, that's it. That's all. So I hope if you have any question, please send me an email and I will try to record a short video to help you. Okay, so let's stop our recording here. Bye. Have a great weekend.